Hello students, welcome back to this session. I hope that I am audible to all. So, in today's session we will be covering theory NCERT section 3.1 to 3.22. A small disclaimer. The images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Thank you. Let's have some idea about preparation related to trigonometry. So some tips that you have to master some fundamentals. Like what? These 6 basic trigonometric functions: sine, cos, tan, cot, sec and cosec. Their ratios, their standard values for 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and their equivalent radian values also. Know the unit, circle and sign of trigonometric function in all quadrant. You must memorize the sign, that what function is positive and negative in among the 4 quadrants: first, second, third, fourth. Then you have to understand some key identities like Pythagorean identity, the double angle, triple angle formulas, the half angle formula, and also very important, product to sum trigonometric identities and sum to product identities. Now you must have idea about the graphs of your functions, those 6 functions, their periodicity, their behavior, in what value the function going to be 0 and assumes or goes towards infinity, at what value, the domain and range. These all will be very easy if you visualize their graph. And obviously you have to avoid some common points, that don't substitute values or identities blindly. Always check the range and domain restriction. And of course, this is very important whenever you are dealing with the ITF, inverse trigonometric functions. And obviously in mathematics you have to practice a lot of problems. Now some recommendations, books recommend. For boards, you can, if you are from CBSE, ICSE or state boards, mainly the suggested books, you prefer those books, and obviously NCERT. And for supplementary material, you can refer to R.D. Sharma in mathematics. If you are preparing for JEE mains and advanced, then you have to go through Senge's trigonometric problems in trigonometry, Senge's trigonometry, and obviously this problems in calculus of one variable by I.M. Aron. And if you are preparing for Olympiads, then Challenge and Thrill of Pre-College Mathematics by V. Krishnamurthy. You can refer these accordingly. Now, in this session, we are going to cover 3.1 section related to introduction to trigonometry. Then what do we mean by angles, 3.2 section. Then section 3.21, we are going to know about degree measures, how we define it, what it means. And finally, we'll be seeing a radian measure, why we require or why we are having different measures. Now, little bit of what? Origin of trigonometry. So this word trigonometry comes from Greek word. What words? Greek words? Trigon and metron. Trigon related to triangle and metron related to measurement. So combined, they means measuring the sides of a triangle. So it was first developed to solve geometric problems involving triangles in Greek region. So what will learn, what you are going to learn? Simply the generalization concept of trigonometric ratios to trigonometric functions. So in previous classes, if you recall, you have seen ratios, trigonometric ratios. Now in this specific chapter, trigonometric function, you are going to see how we transform this or how we generalize this trigonometric ratio concept to the trigonometric function concept. And obviously we are going to study about their properties like periodicity. Now let's recall something. Suppose you are having your right angle triangle ABC, right angle at B vertex simply. Now this BC side is your base, this AB is your perpendicular side of your right angle triangle, and this AC is hypotenuse simply, and this BC and AC both making theta angle. So theta is one of the acute angle, acute of meaning your angle in between 0 to 90 degree. So sin theta is your ratio, what? Perpendicular by hypotenuse. So sin theta is your ratio of perpendicular and hypotenuse. Cos theta is ratio base to hypotenuse. Simple. Now for other ratios, I am just recalling things. So tan theta is your ratio of perpendicular to base. Cosec theta is simply hypotenuse to perpendicular. Sec theta is simply hypotenuse to base, and cot theta is simply base to perpendicular. These ratios are defined only for acute angle in the context of a right angle triangle, because all the sides are positive and the triangle exists only for what angles? If you are considering your theta in between 0 to 90. Clear? So one of the angle is your 90, obviously you are at B, and other two remaining must be acute. Clear? So now definition of angle. An angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side. The final position of the ray after rotation is called the terminal side. And the point of rotation is vertex. Now, types of angles based on the rotation direction. So, we have two types. One is positive angle. Here we are having this rough representation of our angle, of a positive angle, showing the vertex, the terminal side and the initial side. As you can see, OA represents your what? Initial side. OB represents your what? Your terminal side. And this O, where you are rotating your side OA to OB, this is your vertex O. So point of rotation is simply your vertex, in this case O. Now if you go from initial to terminal side in anti-clockwise direction. In what? Anti-clockwise direction. Anti-clockwise means if you follow the needles of clock the movement is clockwise. The opposite direction, the movement of opposite movement to the needle of your clock is simply anti-clockwise direction. So the angle is said to be positive if the direction of rotation is anti-clockwise. Simple. So if you are moving anti-clockwise or your rotation is anti-clockwise, meaning you will say that your angle is simply positive angle. Clear? Moving to next. Now, the second one, negative angle. So, when you rotate initial to terminal side in opposite to what? Not opposite, in simply following the movement of needle of your needle of what? Clock. Clear? So, if you are moving following the direction followed by simply needle of your clock, so you will say that the given angle is your negative angle. If your movement is clockwise, simply clockwise is your term related to negative angle. So if the direction of rotation is clockwise, you will say the angle is negative. Now measure of an angle. So suppose if you started from initial side and rotated, and your terminal side is also your initial side, meaning you rotate completely. This will give you what? So the measure of an angle is the amount of rotation performed to get the terminal side from the initial side. So this specific image is simply of what? The complete rotation. And this, if you follow this arrow, this shows that we are moving anti-clockwise. So this angle must be positive. Clear? Now, units for measuring angles. What are the units we are going to follow? There are several units. One unit is defined by one complete revolution from the initial side's position. This is useful for large angles. For example, 15 revolutions per second for a spinning wheel. Simple. If you are having your wheel, it is rotating, simply rotating, meaning revolutions. You are having your revolution. So how many times your this wheel is revolving at its axis? So you will say, particularly in this example, 15. Clear? So this is one way to represent your movement of your angle. So 15 revolution per second. Two other commonly used units, simply degree measure and radian measure, which will be described further as you go deep into this session. Clear? So simply one complete revolution is one way to represent your angle, your rotation, your revolution for and this is mainly used for what? The large angles. Okay. Now we comes to this degree measure. If a rotation from the initial side to the terminal side is simply 1 by 360th of a revolution, the angle is said to have a measure of 1 degree. So by definition, 1 degree is nothing but the part of a revolution. And what part? 1 by 360th part. 1 by 360th revolution, simply. This much of revolution will be your what? 1 degree. You are naming that as 1 degree. Clear? It is written as 1 degree. Now subunits of a degree. Simply we break degree into minutes. So in general, a degree is divided into 60 minutes. So 1 degree equivalent to 60 minutes. a minute. So 1 minute is simply, you can break minute into seconds, and the relation is 1 minute 60 second. So 1 minute equivalent to 60 seconds. Now 1/60th, meaning 1 by 60 simply of a degree, is called a minute. So written as 1 minute. So minute notation is simply this, represented in blue, 1 minute. So 1 raised to the power this prime or dash, small dash. Okay. Now 1/60th, meaning 1 by 60th of a minute, is called a second. Notation 1 double prime. So this represents your what? 1 second. Now relationship between units. So 1 degree from above, we are having 1 degree equivalent to 60 minutes. So we are using notation, and 1 minute is equals to 60 seconds. Clear? Now examples of angles in degree measure. Simple. So 360 degree. So this 360 gives you what? 1 complete revolution. Clear? 1 complete revolution. In 360 degree, we are having initial side same as the terminal side. So initial side, for notation you can see OA, and for terminal you can see OB. Both represent the same array originating from 0. 0 is your vertex, and this 360 is your what? If you follow this arc, this pointed arc, which shows what? This shows that movement of your rotation is anti-clockwise. So this 360 is your positive angle. Clear? Now 180 degree. So simply this. So this is your 180 degree. Initial side OA, terminal side OB. Clear? And the movement of your rotation is also anti-clockwise. So this 180 is also your what? Positive angle, 180 degree. Now some other examples. 270 degree. This is our visual representation. Simply OA represents your initial side. OB represents your terminal side. Movement of your your angle or rotation is simply anti-clockwise. So we are moving 270 degree. Clear? Now 420 degree. This initial side OA, terminal side OB. If you observe this, that first of all 420 degree represents what? So you are, first of all, you are taking 1 complete revolution. Yes, as 1 complete revolution meaning 360 degrees, and this is greater than 360 degree, meaning we are completely moving around O first of all, and obviously some extra. So some extra would be what? In this case 360 plus 60 gives you 420. Clear? So this OB will be your what? At first quadrant. If you try to see, this OB side will be at first quadrant, but after completing 1 revolution. So this is indeed your movement anti-clockwise. So this angle is also going to be 420 degree. Clear? Now examples of angles in degree measure. So suppose minus 30 degree. This gives you what? So you are moving clockwise direction. So you are rotating in clockwise direction. How much? Magnitude is 30. So this symbol minus or this sign just gives you the direction of your movement, clockwise or anti-clockwise. So positive represents your clockwise movement of your rotation, and negative sign represents clockwise movement. So positive anti-clockwise, negative clockwise. So as you can see from this representation, initial side OA, this negative, we are moving in clockwise direction. So following the clock path, clock needle's path. So the final position OB. Clear? The magnitude of your movement of your rotation is simply 30 degree. Now minus 420. Again, this minus represents your clockwise movement. And this gives you what? Simply OA as your initial position. Following clockwise rotation, first of all, you have to make a complete revolution and then some extra movement, which is what? After complete revolution, you have to move 60 degree more in clockwise direction. So the final position will be at OB. Clear? Now, radian measure. So definition. So radian measure is another unit for measuring angles. An angle subtended at the center of a unit circle. So circle we are taking as so circle with radius 1 unit. So angle subtended at the center of a unit circle by an arc. Arc length of 1 unit is said to be have a measure of 1 radian. So example, OA, take OA as a initial side and OB as a terminal side. So 1 radian is simply this. So O is your vertex, OA is your initial side, moving anti-clockwise. After moving, so if you are moving and your final position is a OB, and this AB, if you see, if you are seeing this circle and this AB is of what length? This part of your circumference of your circle simply is of 1 unit. So we are taking 1 unit. If your movement is in such a way that this arc length, so your movement, anti-clockwise movement on the unit circle, taking OA as your initial side, moving 1 unit on the circumference of your circle. So your final position is at B, final side OB, your terminal side, and whatever angle we are having here, this will be your what? 1 radian. So this is our definition of 1 radian in mathematics. This is the way how we define 1 radian. Simply, let me just reiterate. So, what is happening? You are at your initial position, simple as that. You are standing on this unit circle at this point A. Now, you are moving. First of all, you are moving in what direction? Anti-clockwise. So, in this direction. And you are moving how much? You have to move only 1 unit. Simple. 1 unit. 1 unit meaning, suppose if your circle is of 1 centimeter, then you have to move 1 centimeter. Simple. Clear? If your circle is of say with radius 1 kilometer, then you have to move how much of 1 kilometer? Simple. I hope these terms are clear. So 1 unit. Unit is centimeter, meter, kilometer, whatever. So you moved and you reached to this point B after moving 1 unit, 1 meter, 1 kilometer, whatever is your unit. Simple. Now observing, not observing, now just observing that this angle, so whatever we are having here, angle subtended by these two sides OA and OB at the center, we will be calling that measurement, and that measurement we are naming it as 1 radian. Clear? So simply the minus 1 radian is simple. In this we are going to move 1 unit in what direction? Clockwise direction. So simple. So this negative sign represents nothing but the direction change. Simple. So positive represents your anti-clockwise, negative represents your clockwise movement of your angle. Clear? Now examples of angles in radian measure. So OA is your initial side, OB is your terminal side. So this is your radian, 1 whole 1 by 2. Simply, if you are taking, obviously, you are considering your circle of what radius? Unit radius. So in unit circles, indeed you are having your radian equal to your radius. Only in unit circles. Clear? You are going to see. So this half or 1 whole 1 by 2 radian is simply what? You will get this much of angle when you are traveling how much distance? 1 whole 1 by 2 units from A to B on the circumference of your circle, of your unit circle. Clear? Now, what about minus 1 whole 1 by 2? Simple. In this, the movement is anti-clockwise. Whenever you see minus sign, you have to move clockwise. So now movement is a clockwise. So you are having your angle minus 1 by 1 whole 1 by 2 radian as this. So the same goes for here. So you have to travel what? 1 whole 1 by 2 units, but clockwise direction, in the clockwise direction. Here you are moving anti-clockwise direction. Here you are moving in clockwise direction. The only different thing, in both you are traveling how much unit? How much distance? Simply 1 whole 1 by 2. Whatever you are taking as your unit. Suppose 1 whole 1 by 2 meter. Simple. Or this is nothing but 3 by 2 meters. 3 by 2 units in fractions. Okay? This is your mixed fraction. Relationship between revolution and radian. So the circumference of a circle with radius 1 unit is 2 pi. Therefore, one complete revolution of the initial side subtends an angle of 2 pi radian. So observe carefully. Circumference of unit circle. Clear? Now, so if you recall, the circumference length is simply 2 pi r. So r here we are taking as what? 1 unit. So this gives me the total circumference of your unit circle as 2 pi. So first point is clear. We are having our circumference length, total circumference of our unit circle as 2 pi from the formula 2 pi r. Clear? Now, one complete revolution meaning you are you are starting from your initial position OA, and your terminal position is also the same as your starting point or starting position. So this gives you what? How much you have traveled, how much you have covered on the circumference 2 pi. Yes, 2 pi, 2 pi units. Simple. Clear? So this and this revolution gives you what? How many radians? 2 pi radian. Simple. So we are having a relationship. One complete revolution gives me what? 2 pi radian. The second point is clear. Now, general formula for angle in radians. In a circle of radius r. Now, if you are having a circle of radius r and arc length of r, and this will subtend an angle of 1 radian. So, your 1 radian definition for any radius circle is simply what? So, if you are having your circle with radius r, now you are where? You are on the circumference of your circle, and that circle with radius r. Now you are no longer considering your unit circle. You are taking your circle with radius r. Simple. Now if you are walking from your initial position to the final position, how much of r units? Meaning you are walking at the same length as the radius. So the angle subtended at origin or at vertex O, that angle will be your 1 radian. Clear? This conclusion comes from where? From the previous slide, where we have defined 1 radian in terms of unit circles. So equal arcs of a circle subtends equal angle at the center. If in a circle of radius r, an arc of length L subtends an angle theta radian at the center. So we are going to have this thing, meaning your relation. Simple. This represents your relationship as theta is equals to arc length. L represents your arc length by the radius of your circle. Or in another words, you can write arc length is the product of your radius and your theta angle in radian. Clear? Now, moving to next. So, I think this is it. This is our end of this theory session. Okay.